This video explores the architecture of synthetic reality, tracing the rapid evolution of generative models and the escalating threats posed by audio deepfakes in our digital landscape. Our journey begins in the 1980s. From early digital manipulation and motion capture to the AI shift of the 2010s, we have entered the hyper-real era, where synthetic audio and video challenge our perception of truth. At the core of this technology are generative adversarial networks. This system uses two competing neural networks, a generator that creates synthetic images and a discriminator that acts as a detective, driving both toward mathematical indistinguishability from reality. The past decade saw significant breakthroughs, from replacing noisy early models with convolutional neural networks to introducing Wasserstein distances for stability. These mathematical solutions have allowed for increasingly realistic generation. One major breakthrough was cycle consistency. By forcing an inverse mapping, CycleGAN allows AI to manipulate unmapped, raw data without needing perfectly paired datasets, significantly lowering the barrier for entry. These advancements in computer vision laid the groundwork for audio synthesis. Techniques that solved mode collapse and enabled latent space disentanglement have been applied to capture the complexity and variability of human speech. Audio deepfakes fall into a threat taxonomy, ranging from simple replaying of recordings to sophisticated synthetic-based and imitation-based methods. These latter two categories pose a critical threat to our authentication systems. The synthetic pipeline transforms a simple text input into a high-fidelity voice. It involves analyzing the text, extracting acoustic parameters from a target speaker, and using a vocoder to output the final audio waveform. The threat is accelerating. We have moved from needing hours of studio-quality data to requiring as little as 15 seconds to clone a voice, thanks to multi-speaker models that leverage shared patterns across voices. These capabilities have already been used for high-yield financial fraud, including CEO impersonation and bank heists. These cases highlight a key vulnerability. Our current voice ID systems are often insufficient against such spoofing. Beyond finance, deepfakes are being used to subvert democracy. From fake audio releases during elections to robocalls impersonating political leaders, the potential for mass misinformation is a growing global concern. We are also seeing state-sponsored disinformation campaigns and unconsented commercial use of voices. These escalations demonstrate how easily synthetic media can be weaponized against both organizations and private individuals. To combat this, forensic experts use detection architectures that pre-process audio, extract features, and apply deep learning to classify samples as real or spoofed based on digital artifacts. However, detection models face challenges. Linguistic bias, accent degradation, and sampling rate bottlenecks can all create blind spots, effectively hiding the artifacts that forensic tools rely on to flag manipulations. To address these risks, emerging defenses include cryptographic watermarking, advanced analytics focused on emotional cues, and stricter government regulations regarding synthetic media and user identity verification. Ultimately, we face a permanent arms race. Barriers to creation have collapsed, detection remains a reactionary science, and we must shift our defense towards systemic infrastructure, cryptographic provenance, and continuous auditing to verify digital reality.